This is lab number 1, charged tapes. In this lab, we learn about how neutral objects can become charged via contact, and then we figure out how to determine the sign and magnitude of that charge. So some important physics principles that we need for this lab include Coulomb's law. That tells us about how charged objects interact with each other, and the electric field formula for a point charge, the electric force of a point charge, and the momentum principle are important to understand, and we also need to know how force diagrams and the superposition of electric fields work. So for this experiment, we created charged pieces of tape via sticking two pieces together and pulling them apart. And then we observed how it interacted with other objects to determine the sign of the charge on the tape. And we set up an experiment to create an equilibrium and calculate the magnitude of that charge. In determining the sign of the charge, we observed how it interacted with other objects, including neutral objects that it was attracted to, which we expect because of polarization. We saw that the tapes repelled each other, so that means that they're the same charge. And we saw that it was attracted to a plastic pen that was negatively charged, so we can conclude that the tape must be positively charged. Part 2, we set up an equilibrium where the tape was floating between two objects because we brought another piece of charged tape up underneath it, and that caused it to float. And so drawing a force diagram, we see that the forces present here are the electric force of the bottom piece of tape and the force of gravity. And knowing that the net force is 0 because of the momentum principle, we can calculate Q once we measure the mass of the tape and the distance between them in equilibrium. And we got 1.4 times 10 to the negative 8 coulombs. We can also compute some other values using those formulas, and that includes the gravitational force on the tape, the electric force on the tape, the number of deficient electrons, because it's that positive charge there, and we got a number that's much greater than 1, and that's a good sign because that indicates to us that there is a charge on the tape. If it were less than 1, then if it were greater than 0 and less than 1, then that would not be possible because it can't lose less than 1 electron. And then we were also able to calculate the ratio of deficient electrons to the number of atoms on the tape. And since that number that we got is less than 1, that's also a good sign because if it were 1, then that would mean that the tape gave up all of its electrons and essentially it would be destroyed, which did not happen. So some important assumptions: we had to model the piece of tape as a point charge with the charge centered at the center of the tape. We had to assume that our measurements were accurate, including the distance between the tapes, which is kind of hard to eyeball, so we have to assume that our estimate there was accurate. And we have to assume that no other forces are present there, including air resistance, other charged objects in proximity, and that the charges of the pieces of tape were equal, which is pretty reasonable because they are the same size material and underwent the same charging process. But it's an important assumption to make. We also have to assume the arrangement of atoms on pieces of tape in order to make those calculations about the atoms on the surface of the tape. So consider this alternate scenario if electrons were positively charged and protons were negatively charged. Essentially, the tape in this experiment would be negatively charged since it has an electron deficiency. And likewise, the charged pen that was negatively charged would actually be positively charged here since it has excess of electrons. The magnitude of the tape's charge would be the same, but the sign would be the opposite. And the force exerted on the tape by the other piece of tape would be unchanged since it relies on Q squared. But the electric field would be in the opposite direction. We can create a computational model that shows the pieces of tape and the Earth as objects and computes the electric force and the charge on the piece of tape. And here is the output. The visual shows the force of gravity as the green arrows and the electric forces on the tapes as yellow and red. And we found Q equals 1.4 times 10 to the negative 8th, and that agrees with the quantity that we calculated by hand.